Hello everybody, the Lord Root here, and in this KSP tutorial we are going to revisit the topic of rocket design. So let's really talk about, I suppose, some engineering concepts to begin with. It's good to know not only how we're going to do something, but what it is that we need to do in the first place. And so, as you might recall, our goal for this episode is to create a craft that can dock with our newly orbited space station. And some things I have in mind are a reasonable crew capacity, maybe a 3 or so, because if we take a look at our Kerbals, I'll just put down a pod, one that I think will be suitable for this. We have 3 Kerbals that we can send up right now, and that is all well and good. But there are other things as well. For instance, we might need to dock to the space station, so we need that. We need bind control over our capsule. And then we have a pretty good idea that we're not going to be sending this out of low carbon orbit. So that changes a lot of things compared to, let's say, if we were sending this guy to Minmus. And in that case, the way we want to build this is we want to consider our trade-offs. So we have trade-offs between mass and delta V. For instance, the less mass we have, the more delta V we will have with the same rocket. We have, in some cases, aerodynamics to contend with, because right now this object will have a little bit of drag associated with it. And not only that, but if we were playing career mode, we would have cost and part availability to consider as well. So these are all things that make it into this sort of discussion. And there's some questions we're going to ask. For instance, will this thing always be crewed by a pilot? We have pilots here, but maybe not necessarily. And in that case, we will want to do something about that. One way we could solve that issue is we can put a probe core on top. And if we just take a quick look at this, there are numerous ways for us to consider that. We have this remote guidance unit here, which has it's 0.1 tons, right? But then we can go to the utility here, and we can compare that to maybe this guy. This is 0.3. And so, this is an interesting question. These service bays, as you may remember, allow us to basically stick things in them. That's actually the small one. This guy's the same as the controller here. And as a result of that, if we wanted to collect science, for instance, or have some instruments here, then we could do that. We could, for instance, put a small probe in here, maybe something like this, that's 0.04 tons, and stick some scientific instruments in there. Do we need to do that? I really see no reason why we should, but that's one thing to consider there. If we do want to stuff instruments in this thing, then maybe this isn't a bad idea. So that is one thing to consider. I'm just going to right now go with this RC001S, and that will be kind of helpful for us. Oh, pardon me. Now, as a result, one thing we can do here is we know we've got to dock here. So we can put a docking port down. And actually, this brings up an interesting question. Between these two guys, which is better? And that really depends how much you care about your Kerbal safety. So for instance, there are going to be cases where we might want to escape from a rocket. And in that case, what we would do is we would take something like this. I'll just do the center of mass deal here. And I will grab a stack separator here, throw it on like this, and then throw on our this escape tower. And this means that whenever we get close to this guy here, you know, we can, if we have to jettison that, then it is possible that, let's say we have a little rocket here, and I'll just show you an example. I'm going to give this a name, maybe Hermes Mark 1. And what we can do with that is we can take this guy. Let's say we're on a rocket of some kind, maybe something kind of like this here. And we have a small fuel tank, relatively small, and we'll just put something like that. And let's say we have this guy here with this ridiculous thrust to weight ratio. Well, if we go to our action groups, we can go to our abort here. We can activate the engine and we can decouple. And if we put parachutes on as well, and we'll just do that now. This thing will probably take about 2 parachutes to be able to land properly. Then, what we can do now is we can go out here and when we try to launch this, we can move this guy down here. Uh-oh, we've had an accident. And we can rescue the Kerbals. Now, of course, there are issues with that. Largely because of the fact that one of the problems we have is that this thing is so heavy. And that is not so good. It does get us out of the way. But maybe we would want to rely on something else. That decision is totally yours. I am going to leave it on for now because I like the way it looks. But, you know, we got other things too. We've got to, for instance, consider our power usage here. And so, one thing to consider with these is that unless you're constrained for parts, it usually never hurts to put these solar panels on because they're massless. That might come into play if you have a part limit there. But in this case, you know, we can take this guy, we could maybe put an engine on. What kind of engine do we want? Well, that totally depends on the spacecraft. And the idea here is that you're really trading off between thrust and delta V here. So in this case, we have an effective thrust at a sea level of 207 with some 137 meters per second at delta V, which is respectable, to say the least. However, we now have this one issue to where this stage by itself weighs over 6 tons. This is about the tank itself is about the same mass as it has the same amount of fuel, in fact, as one of these guys here. And in orbit, we may not need so much delta V. So what we could do is we could stick something on like this, and we could maybe go with a slightly less efficient engine, maybe like the LV909, which has about 5 seconds less of vacuum delta V. And we do get slightly less delta V like that, but because we're going to orbit, or we will assume rather that we're in orbit, that may be acceptable. So something like that, we have dramatically decreased the size of our service module, and therefore potentially increased the amount of delta V we have. And there's something else too. This actually will change because of the fact that if we put an engine under this, then let's say we have something kind of like, I don't know, we'll grab a decoupler and do something kind of like this, to where we have maybe something like this here. We have the one engine here. We'll put a main cell there, and we will jettison this guy here. So we'll move this up into a separate stage so that we can use it. Maybe something like this. And in total, that means that for this guy, we have to be able to lift 9 tons, which isn't bad. We might even do like that, maybe get a little bit more in the way of delta V here. But there are other things to consider too, like for instance, where is the center of mass on this thing? Because we need maneuvering thrusters. It seems to be pretty close to that decoupler. At least close enough to where maybe it looks like it's on the edge here. Now this actually brings up an interesting question. Do we need a heat shield? Well, from low orbit, if we play our cards right, we won't. What we will need to do, however, is make sure that we do not land very aggressively in the process. Now, there's some things here that we can do here. For instance, we may find it necessary, now that we have all of this fuel here, that we can utilize all of this RCS fuel. You know, when this thing's attached, we may want to have some extra fuel for maneuvering. Something like this, we have about 30 units, which it's possible it could be enough. Sometimes it's not, and that's something that you need to take into consideration. Because adding in RCS fuel does increase your mass just a little bit. Okay, so anyway, we've got this one issue to where this guy isn't structurally sound anymore. And there's a couple of things we can do to deal with that. And the first I'm going to do is I'm going to take one of these little adapter plates and I'm just going to run struts up the center like this. And that's a perfectly reasonable thing to do. This also will tend to cause aerodynamic problems as well. So you may find it necessary to come in here, grab you a fairing, and make you a little interstage fairing. Now this is important. You can see here we've got the mass down here. We want to make it under that 12 tons that we initially had. Of course, with the interstage fairings, what you want to do is you want to get this thing blue and you want to close the fairing. We're about where we were earlier with that, but this gives us some advantages as well. Let me just do something kind of like this here. Now you can jettison these guys in space if you want to. I personally think it's not a bad idea to do so. But you know, we'll want solar panels on this, for instance. And these guys here, as you may remember, once you open them up, they are going to be open for good. That may be okay in our situation, however, because this is a one-use vehicle. So what I'm going to do is I'm going to action group these guys up. I like to have my solar panels on one, and because we can't close these up, I'm just going to extend the panel. Here are some things to consider as well. If we're docking, then it is entirely possible that we will run into this one issue to where if we have our solar panels too close to things, then they'll break, and we don't want that. So I'm going to put those in the rear. Now for a small vehicle such as this, we also want batteries, and the massless ones will do just fine. We can put, we don't even really need 4 of them, but 4 will do just nicely. And that means we now need to consider a second stage. Depending on your design, you may or may not wish to have one. On the one hand, having a second stage is a pretty good idea, just because of the fact that, you know, let's consider the fact that we might have something kind of like this here, where let me take out that erroneous stage there, where we want to be able to push this thing in like so. That means we're using this to lift a 21-ton vehicle, and for our purposes that's probably okay. 21 tons is not that much, and it'll make our vehicle more sprightly. But we have to consider, we need some, oh, I don't know, I think it's 3,500 meters per second of delta V. And you can see right now we've only got 615. This is not going to get us remotely close to out of the atmosphere. Now there's a rule of thumb here, which is that you need less thrust to weight ratio as you get higher up in the atmosphere. And in that case you can use smaller engines. And you can stage this guy pretty easily as a result. So let's make this assumption that we've got something that'll get us in the atmosphere at least. Let's say it'll get us 2,000 meters in. Then what we can do there is we can grab our fuel tank. We will work with the assumption that we're on ground level, and by the time we get to that 2,000 meters, we will have more than enough, velocity here. Engine design is kind of critical here. This is not a good situation. It gets us, on the one hand, it does get us close to what we want to do. On the other hand, we can't lift off with that. We need at least at least a thrust to weight ratio of 1 to overcome gravity. It is very likely that we will want a thrust to weight ratio closer to or maybe 1.2. And so this won't work for us. That means we could put a mainsail down, and if we do that, then what we find will end up happening is that we have just about the right level of a delta V here, because we have 2,500 with actually quite a fast escape. That should get us up out of the atmosphere. And then in addition to that, we have this guy here that will give us another 1,600 meters per second of delta V. And in fact, we've sort of seen here that we have an excess at that point, because this guy stays mostly constant. If we subtract 100 from that, we have over 4,000 meters per second. And that is more than sufficient to get us into orbit. So there are some things here we can do. For instance, we can revise that and say we don't need nearly as much for this guy anymore. And that's down to 900. That brings us down, if we go to our atmospheric issue here, we have 2,700 plus 900. That gives us 3,600 meters per second of delta V, and increases our thrust to weight ratio to boot. So this is something that is worth considering when you design this sort of rocket. And I'm just going to call this Hermes Mark 1. As a result, we're not going to fly it yet. This is a perfectly reasonable rocket to fly, but occasionally you'll find yourself in a more constrained situation, because, like, well, the thing we might want to do here, for instance, is we might want to use this, and we know that this guy weighs some 6 tons, I think, is the weight of that engine, of that main cell. We have a mass of 3 tons here and a mass of 6 there. And that means that we can reduce our fuel load if we can at all get this guy to do his thing, which would give us a shorter rocket and would, in effect, just barely allow us to get off the ground. But we're somewhat short here, and we will not have enough Delta V to have a full tank. And you know, sometimes having a full tank is actually not a bad thing, or it's not something you have to have, rather. Well, these are engines that up until recently I had completely forgotten about, and they're particularly useful if we want, for instance, in this case, we want to have this guy going to where it'll use slightly less Delta V that way, but, or have slightly less Delta V, but in this case we can use this for fine control. And we can have these little outboard engines here. I'm going to reduce it to maybe 2. And in that case, I'll just put them out here for aerodynamic effects. And we now have 3,000 meters per second of Delta V, and a fair amount of control there. And that's compared to maybe something like this, which this has a mass of 42, whereas this only has a mass of 13. On the other hand, this has slightly better engines and a ton of thrust. And when you're lifting off, thrust really is a big deal. You want your thrust to, as you move up in the atmosphere, you want it to really, you don't want to lose too much of it. You don't want to lose velocity when you use your, when you put your thrusters on. But we all, this is good if you don't have gimbling on the engine. I have gimbling on this engine, so it's not so good for me. Instead, what I'm going to do is I'm going to put little side boosters on this. And you can get really crazy with this. For instance, maybe I want to set up these small guys here, like so. I'll just get this guy over here, and we saw this a little while back. You can see that we'll put this guy here, and we will come off the side. That now gives us the one issue to where, let's just move this guy down here, for instance. We have the Delta V now. In fact, we have plenty of it, but the thrust is lacking. So what might be useful for us then is to take these Reliant engines and throw them on the side like this. And when we put these two in the same stage, then what will happen is that we will get, we'll get something kind of like this, to where we may or may not be high up enough in the atmosphere for this to make much sense. Or we could certainly do it. I'm going to put some nose cones on as well. And you do want to be careful, by the way. Like, these guys will probably cause a lot of drag. And in my case, I want to get them as close to the center here as I can. So I'm going to do something kind of like this. And now these guys are pretty well situated. We can strut them up if we want, and we should in reality. And we remember the trick for strutting. Can do something kind of like this here. That way we always get an intersection with whatever it is that we're messing with. Just like that. And we'll just move this guy down here and this guy up here. Well, maybe something kind of like that. Now, what we can do, once we get this guy moved up here, is we can make a subassembly out of that. We remember how to do that. We'll just call this boosters. Or something kind of like that. Side booster. But let's say that we're not happy with the fact that we have very little thrust to weight ratio there. So what we've decided is that we want to maybe make this thing a little bit more compact so that it has a higher thrust to weight ratio whenever we release this. Well, that can be done. We'll put the smaller tank on here. This guy will sort of attach to the fairing like that. Now we're in an okay situation here. We have 2,600 meters per second at delta V. This is right at 3,500. This could get us into orbit. Probably wouldn't leave us much wiggle room. So another thing we can do here is we can put two more of these boosters on here. And we're going to do something differently this time. What we're going to do is we're going to take these guys here. Let's compare our radius here, or our delta V here. We have, at the moment, before we get up to that stage, 1,300 meters per second. And there's a way we can actually make this a little bit more efficient. We can take that fuel duct, and we can now run this guy over here, like so. And that gives us an extra 100 or so meters per second at delta V, which is very helpful. It means, in particular, that we can use this stage possibly to do some circularization. We maybe take a shallower entry, which will help us possibly obtain a better thing in the long run. I'm gonna call this asparagus, after the asparagus staging. And we now have a good amount of thrust away ratio. We don't drop in speed suddenly. And we should get up to about 10k or thereabout with this. Now, if you are concerned about having a little bit too much fuel and you want to save some weight, you can calculate, because we know this is going to be roughly out of the atmosphere. You can say, okay, we know that we have about 3,000 meters per second already. And so in this stage, we will only need, let me just bring this up, maybe like 300? Oh, 400, good measure. So we have 500 here. And here we have almost 3,300, so that will be enough for us to get into orbit. So which of these is better? Well, it really depends on what your criteria are for better. I mean, this does have the disadvantage that this is about 70 parts, and in terms of weight, you know, we have 87 tons here. If we go back to this other guy, the Hermes that we did without the asparagus staging, then it's less, which makes it a little bit more sprightly. And it also happens to, at least from our perspective, be a little bit more performant. It costs a little bit less too, which, you know, cost isn't something that you worry about too much. At least not for sandbox mode. But for other things, maybe like career mode, maybe cost is something you want to think about. So, you know, this at least has half as many parts. And the other thing has 10 stages, right? So, the nice thing, or the reason we really care about the staging is because of the fact that the staging is, you know, we care about that largely because there's more that can go wrong with that. Well, I'm going to save this, and I'm going to launch. Okay, let us launch this guy, and we will see how this thing performs. Okay, that was main engine cut off there. We are getting pretty close here to being at orbital velocity already, and I'm doing some maneuvers here. I'm doing a radial maneuver to really do two things. One of them is to bring down our prograde vector, which was pretty high up to begin with. And the other, of course, is, well, really we need to be paying attention to this. We're a little bit ahead, so we can stand to come up just a little bit. And right now we're just a little bit past this. We still have plenty of delta V left. We use that here to raise our apsis just a little bit. It's probably better at this point. We're ahead, so we want to be behind. And there we go. Some issues with the fairing separation, but it is now possible, at least, for us to, you know, we could actually do our rendezvous pretty easily here. Just go to the target here. As we get close to our target, our pointed target intersection, that'll happen in about 6 minutes. And I'm just going to deploy our solar panels. Because we'll want them eventually. Right now, it is possible for us to, doing this burn here, to very quickly get up and on this thing, and that's something that I'm interested in doing, largely because we have the fuel for it, first of all. Okay, we're close to final approach here. And that, of course, means that we're getting ready to dock. So this guy, in fact, could get out to the space station. Has more than enough Delta V, in fact. Could probably go to the moon if we wanted it to. Just based off the amount of Delta V we have. And, really the only thing left to test here is whether or not we can meet up with that docking port there. I think that that's going to be a good thing to do. Oh, this is the wrong one, actually. It's a Lampatron Senior. I think that one there is one that'll work. But if you take a look at that, our vessel mass is about 3 kilograms, which is respectable for something like this. Unfortunately, we came in on the wrong side, so I'm just going to, I'm going to get lined up here and skip on past that. Might even help if we align ourselves just a little bit, where we get more out of this. The RCS does seem to be fairly balanced here. Maybe one thing we could have put on this was lights. But yeah, we're just going to ease on in there. And that will give us a fully populated space station. So we know that this craft is capable of doing what we want it to do. It has more than enough delta V to get out of orbit. And, really the only thing left to test is re-entry with this guy. Now I'm thinking, if we do this correctly, that re-entry will not be a problem. Just, we just want to get out of the way here. And find retrograde, which I believe is somewhere around here. And I'm not going to worry about where we land in particular. I'm just going to be worried about what our re-entry altitude is like. I think that's a fair altitude. It may not be such a bad idea for me to dump this stage, given that we're not aerodynamically stable by any means. And we will heat up quite drastically. So we'll say goodbye to this stage for now. We have a little bit of fuel left, so we can use it to get out of the way here. And you know, in some classic spaceship designs, the RCS actually was used during re-entry, so it's not really such a bad plan. We just have to bite down into the atmosphere here. And hope that we're not going too far. There we go. Let's turn on the thermal monitor. We are heating up just a little bit. Hopefully not too much, but we are losing a lot of velocity, and all we're really concerned about is the drag here. And generally for re-entry you want a capsule-shaped object, because it's aerodynamically favorable. Yeah, I guess the only thing really left to do are to make sure we can land on those parachutes. Maybe it's not the best thing to do it with people in it, because this sort of test is not such a good thing to do when you have Kerbal's lives at risk. But we'll deploy that. There we go. It's a little bit heavy, some things will probably break, but the capsule can handle landing at this altitude, or at this speed. And what's a couple of RCS thrusters anyway? Apparently nothing. Anyway, I hope that you learned something and that you can take this and do something with it. But At any rate, this has been Dialord Root, and I will see you later.